Hello, Internet, and thank you very much for joining us on the Cloud Native Islamabad workshop. I'm your host, Saim Safdar, the co founder of Cloud Native Islamabad community. And this workshop is hosted on Cloud Native Islamabad because and we are the CNCF local chapter. I'm running in Islamabad, so all the code and conduct is adheres to CNCF. So I hope everyone being welcoming to everyone on the chat. So let me introduce a small bit about what we are covering today. Istio Ambient Mesh implements a sidecarless architecture that is transparent to the workload in the mesh. This approach provides a number of benefits, including incremental adoption, improved operation, and more. This hands on workshop will help you better understand how Istio Ambient Mesh works. First, you will need to install Istio using the new ambient profile, which will install the Istiod control plane along with data plane components such as Istio ingress gateway and ztunnel. After that, you will learn how to onboard service into the mesh, and you will explore several capabilities including layer 4 authorization policies, layer 7 authorization policies, layer 7 observability, fault injection, and traffic shifting. This workshop is intended for developers and operators. Anyone responsible for the delivery of microservices will find the workshop valuable. We assume you are just learning about Istio and Service Mesh. And this is part 2, and part 1 we already covered on this YouTube channel, diving into the world of Istio Service Mesh. And if you can search on this YouTube, and you can enjoy this session afterward as well. So let me introduce my guest, Mourinho Vijay. Thank you very much for joining us once again. And today is the last workshop I'm hosting, and it's been a pleasure talking to you. So let's start the agenda first and with your small introduction.
Absolutely, absolutely. Thank you so much, Simon, again for having me. I am honestly honored, humbled to just be able to be here and do the very last one of the year for you. So I'm excited. So hello, everyone. I'm Marino Wijay. I am a developer advocate at Solo. I focus on a variety of different things. If you caught me last week, I talked a little bit more about that. Last week, or sorry, the last time we were on the stream, we actually covered Istio and what its capabilities were. And we even dove into a little bit of a lab environment so that we can get a sense of how Istio functions in a production or even a Kubernetes lab environment for that matter. Now, today, what I intend to cover is there's a few areas I just wanted to recap and cover up because we didn't have enough time to finish off the lab last week or the last time we did this. But today we'll cover a little bit of that, and then we'll dive right into the new flavor of service mesh, ambient mesh, which is still Istio, but it's another option inside of the Istio service mesh offering. We'll talk a little bit more about its capabilities and how it brings some new capabilities to the table while still retaining the same features of Istio and the Istio service mesh. So I'm going to go ahead and share my screen. I'll quickly present a deck, and then we'll jump right into the environment. By the way, everyone should have access to the environment, and the environment actually is for all. So one of the nice things about this environment is you don't have to actually build your own. It's a sandbox environment, so you can go in and you can play. You don't necessarily have to do any sort of prerequisites or anything of that nature. It's very, 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 very straightforward. So I'll bypass the intros, but if you want to follow me on Twitter, you're more than welcome to, or catch me anywhere else. But let's briefly just talk about Istio and where it went. So in 2017, Istio was launched because the community noticed a number of gaps in the way Kubernetes handled things like application networking and security and even observability. So Istio was launched and then created a few things around ingress networking, as well as being able to extract observability at the application level while also introducing this element of identity and encryption. Now, over time, it evolved to encompass the Envoy proxy, which effectively is today the sidecar resource, as well as the Istio ingress gateway. And the Envoy proxy is a very versatile proxy altogether. you can tune it in so many different ways, but if you had to do this by hand, it actually becomes very challenging to manage. So Istio's control plane drives configuration for the Envoy proxy, which it behaves either as that sidecar or ingress gateway. Now, fast forward to 2022, we announced that Istio will be joining the CNCF and has been accepted into I believe it's an incubating project at this phase right now. So we're hoping that it will graduate in the next year or so. Alongside that, a new mode of operations was launched in Istio, and it's called Ambient Mesh, where it actually now moves away from the sidecar. So there's no longer a sidecar in this version or mode of Istio. But that also brings up the question, is it an either or scenario? And actually the answer is no, it's a both scenario. You may have situations where you have applications needing the sidecar because they're not intelligent enough to route on their own. And then there are instances where having a sidecar may inhibit or prohibit the application from performing correctly. So in these various modes that we have available, we're able to create a very complex network architecture for our applications and fine tune it and customize it to the variety of different workloads. So a perfect example of an application is a server send first application, something like a database, which actually doesn't really take advantage of the sidecar. So using something like Ambient Mesh might be very beneficial. Let's quickly recap how Istio works today, and then we'll jump into how Ambient Mesh works. So in Istio, we actually have a few main components here. We have the control plane known as Istiod, and that's responsible for certificate management and rotation. It's responsible for maintaining identity. It's responsible for service discovery of all the different services that exist in the mesh. It's also responsible for passing along translated configurations towards these sidecar proxies, which are effectively Envoy proxies, as well as the Istio ingress gateway and egress gateway. Now, the other important components here are the Istio ingress gateway and egress gateway, which effectively are the entry points and exit points of our mesh. And then inside of the mesh, we always have these sidecar proxies that exist that work alongside our main service or container. And these sidecar proxies, proxy connections, they are forming the encryption between other sidecars using this MTLS capability or mutual TLS capability. And then they're also providing observability points for our service to tell us if there are any sort of HTTP failures or if there's latency in the traffic request path, or any sort of logs that we might want to derive from the service itself. But in a nutshell, this is the representation of a service mesh, and you can assume that this is inside of a Kubernetes cluster. Now, that being said, there are some key capabilities of the mesh where you might onboard just the gateway or the ingress gateway to be able to do ingress networking and then TLS termination at the edge of your microservices network. So I have a gateway that is the entry point into my cluster, and that gateway will terminate TLS inbound for any sort of any sort of requests that are coming inbound to my services. Now, the gateway is rolled out as a pod service and is backed by a load balancer type service inside of Kubernetes. Now, that load balancer needs to come from somewhere. So normally you would either run this inside of a cloud environment like GKE or Civo Cloud, and you get access to a load balancer. That load balancer IP gets assigned to the Istio ingress gateway and basically will listen on at any ports that you define for that ingress gateway. Now, the gateway also allows in and outbound access. So it is the first entry point. But here's the thing. Once your traffic or requests make it past the ingress gateway, if you didn't have the sidecar present between your services, then whatever request that comes inbound has free reign and can basically traverse the mesh, even though there are no sidecars existing. So this is where we have to consider, do we start implementing sidecars? And this is where we start to move to this sidecar approach where maybe we're not controlling traffic or we're not specifying any sort of policies to block traffic or prevent traffic. However, we are now injecting proxies just to see who's talking to who. Because if we can determine who's talking to who, then we can now paint a picture visually as well as derive our policies from these different interactions. So if the observability capabilities of this proxy are telling me that service A is talking to service B in this direction, now I can create a policy, an authorization policy that allows me to say service A can only talk to service B. But we need to observe this traffic first before we make those decisions and before we implement any sort of policy. Now, once we've gotten to a comfortable state of we know where our traffic is going, we know who's talking to who, we know where the request paths are, that's where we can start implementing some encryption. The encryption then allows us to encrypt the communications inbound to the mesh, and then from the entry point towards the service, and then all the way through that request path to wherever it needs to go. Now, the beautiful thing about this is when you actually go to, let's say, analyze this traffic, it's all encrypted. So you actually don't know what's inside of the payload. And that's very important because guess what? Any sort of data leakage means that there's the potential for personally identifiable information to be leaked out somewhere. And we don't want that. That's an example, right? So this is almost a data loss prevention mechanism by using encryption, because now, even if someone had access to the payload data, it's encrypted. They would need the set of keys to be able to decrypt that. And guess what? They don't have access to it because it's inside of the Istio mesh system. Now, once we're beyond having encryption, there are a few things about controlling traffic. This is the part we actually didn't get to go deep into last time we actually streamed. There's an element of policy. So you're authorizing services to communicate with other services. And this might be at layer 4. So we're just looking at TCP ports and deciding whether or not we'll allow ourselves to communicate with services on those ports. Or we could do this at layer 7, where we can now decide, based off of the type of HTTP request, we can either allow or disallow that request to be made. So an HTTP GET operation or an HTTP delete operation, for example, we may not want to allow a delete operation, but only allow a GET operation. The other thing to consider, though, is, okay, once we have our policies in place, there are other interesting things we want to do around controlling traffic in terms of where we want it to go and how we want it to move in certain directions. So there are elements of mirroring traffic where if I am sending requests out to one direction, I may want to send a similar set of requests out to that second destination here. But if you notice here, why would I have V1 and V2 of the same service here? Now, what I'm trying to do in this situation when I'm mirroring traffic is I'm trying to analyze and I'm trying to understand the kinds of requests and responses I may receive with going towards V2, even though it might not be production ready or it might not be, publicly available or even released for that matter. We're still using the mirroring function within Istio to better understand these requests and the responses. While in actuality, 100% of our requests are still going to V1, we should still expect V1 to provide the correct responses. Now, beyond that, we may be doing other things, like we may be traffic splitting. So assume this is another copy of version 1, replace V2 with V1, and I might have a split scenario where I'm sending 60% of my traffic to this V1 and 40% to this V1 as well. And why I might be doing this is so that I'm alleviating the load of one particular service. Now, this is something Istio does, but you can also achieve this inside of Kubernetes using the horizontal pod autoscaler capabilities as well. And using using Kubernetes proxy, it'll basically load share as well. But this is just a more specific mechanism to control this inside of Istio. And sometimes you might do this if you're doing some sort of locality-based work as well. Now, there's also the element of resiliency, right? What happens if you have one service, you have two copies of the same service, but one of them disappears for whatever reason. And this might be due to the underlying node failing, the network becoming unavailable. This could be due to a variety of reasons or circumstances. Now, one of the very cool things about the way you can control traffic is if there is a failure, that's an indication to now send all traffic towards the second copy. There's also the element of canary releasing and dark launches. Now, I may want to send 100% of my traffic to V1 and then only no %. This is dark launch, so it's up and online, but it's not receiving any traffic. And then when I release it, I may do it in a very phased approach where I do 100%, and then I do 90% of V1 and 10% of V2, and then I do 75% of V1 and 25% of V2, and then I phase this. But the reality is, in production, I'm never going to do this manually. I'm actually going to use a tool like Flagger to automate this process so that it'll go back and check the health of V2 anytime requests are being shifted over on a percentage basis. Now, there's a couple of other things to consider as well. The other things to consider is around resiliency. Resiliency is really about, let's just say in my traffic path here, I have a particular service that needs to respond to another service and get a response from a different service before it can respond. Now, one of the interesting challenges around that is all services are going to respond or provide a response in a different time frame. Now, in that particular situation, your request as a client may time out. Now, how do you fix that? You can actually inject delays into various parts of your services. So this allows your request to wait before it times out. You can actually implement retries in your request flow so that if a service, for whatever reason, is currently taxed, it's just running at 100%, it can't seem to respond. When the retry occurs, maybe it does respond at that time. But then here's the other thing too. This is great for debugging. It's great for observability. If we have multiple retries going on, that could be indicative of a service issue or a service failure. This might be an opportunity for us to dig into it. But this is why we implement some resiliency so that we have a proper expected response time versus letting it all kind of just flow and then hoping for the best. Now, in the previous session, we did not cover the resiliency piece or fault injection. I strongly recommend you head over to academy.solo.io. So academy.solo.io. And once you get there, there is the Istio Getting Started workshop. You can, go through the entire workshop again, or you can just jump to the very last bit, which talks about fault injection and resiliency, and actually test this out. Now, moving on, right? I'm actually going to go take a look at the comments here. Hello, Simon Marino, best wishes. And then okay, thank you. Awesome. All right, let's talk about Ambient Mesh. So in a nutshell, Ambient Mesh is a new operation or new mode of operation inside of Istio. And simply, it just means that we are not deploying the sidecar for workloads that want to be a part of the mesh. So when we want workloads to be a part of the mesh, normally we would use the label istio-injection equals enabled label on a namespace. And any new workload that is deployed into that namespace gets the sidecar. Now, we operate a little bit differently in Ambient Mesh in that we actually don't inject sidecars. We tag a namespace with a label that basically says this namespace is going to be Ambient Mesh enabled. That is an indication to then tell a few new components in the world of Ambient Mesh to effectively direct traffic appropriately, and we'll talk about that very shortly. Now, in the Istio mode or the regular Istio version here, when we have the sidecars here, if you notice, we have a proxy and we have the main container. So anytime we see this, we have a sidecar existing alongside of our main container. Now, this is taxing from a resource and CPU memory standpoint, but it also means a lot of different sidecars to have to be responsible for as well. Now, this doesn't mean that sidecars are going away. It just means that with this new mode of operation, onboarding services into a mesh may be less harmful to your production environment in the sense that you don't have to restart deployments anymore. You can roll out your services into a mesh because there'll already be services running in your cluster. You're just turning on the mesh functionality with Ambient Mesh. Now, what's interesting is Ambient Mesh actually moves the sidecar functionality to a daemon set level proxy. So every node that you have in your cluster will have its own proxy. This is known as ztunnel, as well as something called the CNI node. We'll talk about that once we actually dig into the environment. But these two components here enable the mesh functionality. Now, the ztunnel itself is effectively today, and this is specifically today because I'll talk about this shortly, today is using the Envoy proxy as well. So same functionality. It's almost like we're tuning the sidecar, except the sidecar now lives at the node level. So if you think about this one proxy here is going to service multiple pods inside of your node itself. And then if you have to scale it, then you could use mechanisms like the HPA to be able to do so. Now, this daemon set is definitely going to fall under the realms and resiliency of Kubernetes. So for example, if the node fails, and if you reconstruct the node or re-add the node or a new node is added to the pool, well, Kubernetes desired state engine knows to go and reconcile this and will redeploy the proxy as necessary. So the failure domain or the resiliency is no different than what you would see inside of Kubernetes. Now, the other thing too is Istio's Ambient Mesh still provides you the zero trust functionality. In fact, there's a couple of considerations here. Now, the sidecar itself, because it's Envoy based, uses both layer 4 and layer 7 capabilities. But in Ambient Mesh, that functionality gets split out into two kinds of proxies. One called the L4 proxy, which is the ztunnel that I've kind of briefly mentioned. And then something else called the layer 7 proxy, which is something known as the waypoint proxy. Now, if I am just doing straight up layer 4 connectivity or layer 4 connection, so I have a service here calling a service over here, I will just go through the layer 4 proxy. In fact, these two layer 4 proxies are forming MTLS for us. They're forming the tunnel between the two nodes, between the two workloads. So this workload here will be directed towards this proxy, which will tunnel the traffic over to this proxy over here, which will then send it to its destination pod or service. This is very similar to how something like an IPsec VPN would function. Now, when I need to implement that layer 7 functionality for things like authorization, so I'm trying to prevent services from issuing HTTP delete commands, then what ends up happening is as layer 4 proxy tunnels to this layer 7 proxy, which then tunnels to this layer 4 proxy over to the resultant or to the destination service. But this layer 7 proxy is the intermediary that processes any sort of authorization policies. So anytime I push out a policy, a waypoint proxy gets deployed. Interestingly enough, the waypoint proxy actually uses the gateway API spec that was launched recently in the Kubernetes ecosystem. Now, the other thing too to consider here is that the same Istio control plane will provide functionality both for the sidecar mode and the sidecarless mode. So nothing really changes here from an Istio standpoint and a functionality standpoint. If you want sidecars, you absolutely can get them. If you want non-sidecars, you absolutely can do this as well. However, the one thing to consider here is that things like multi-cluster or things like multi-cloud currently in Ambient Mesh is an experimental feature. So I'll bring this up too. Is Ambient Mesh ready for production? A lot of people have asked me this before. And actually, if you go to the istio.io or the Istio GitHub repo, there is a fork, there is a branch for Ambient Mesh. It hasn't been merged with the main branch yet. And that's just because Ambient Mesh today is experimental for a few reasons. One of the primary reasons why it's experimental is because currently, as it stands, we use Envoy for both the ztunnel proxy as well as the waypoint proxy. Now, Envoy, as powerful as it is and as highly capable as it is not the right vehicle forever in terms of having to do this with Ambient Mesh, because it actually still consumes a lot of CPU and memory. That being said, the Istio community has started exploring a Rust-based proxy variation that will provide the same set of capabilities that Envoy did. In fact, if you go over to the Istio GitHub repo and head over to the Issues tab, you will see that there is a pull request waiting there that discusses using a Rust-based proxy. Now, that being said, this will optimize the way traffic moves around. It'll optimize the flow and latency, and a lot of other benefits too from a memory and CPU standpoint as well. Now, there's one more thing I'll add. With the same Istio control plane, you can do both. You can actually do both sidecar mode and sidecarless mode, and we'll see that in the lab. The other thing to consider too is that if you're looking for more supportability beyond just experimental, this is where Solo's glue platform and glue mesh comes into the mix here. Solo's actually written a bunch of abstractions on top of Istio to provide a simplified experience. But not only that, because of the ambient mesh launch, Solo has also provided abstractions to be able to manage ambient mesh deployments inside of the glue platform as well. So that means if you want support for ambient mesh, come to Solo. A couple of more slides, and then we'll jump right into the lab environment. Now, in this environment, right, or inside of a, let's say a Kubernetes cluster. Oops, let's just say we have one cluster here, or sorry, one node here and one node here. We have app A, C, B, and we have app B, D, C on this side as well. Now, if you notice, there's something called the CNI here. There's a ztunnel, there's the waypoint, and then you also see a ztunnel on the CNI here as well. Now, if app A wants to communicate with app D over here, one of the things that goes on is that the CNI pod, there's a CNI pod that's deployed, as Damon said as well. It's actually looking for traffic that is ambient mesh bound. When it sees traffic that is ambient mesh bound, it sends the traffic or redirects that traffic towards the ztunnel. That ztunnel is then going to go ahead and assume the identity using the SPIFFE ID format from app A using its service account, and then we'll use that as the basis to form its end of the MTLS tunnel. Now, assuming this waypoint proxy wasn't here, it would just be a direct tunnel to this ztunnel over here. The same applies even if you had the waypoint proxy in the mix. But the consideration here is that this ztunnel also knows that traffic is coming inbound, so it's going to derive app D's service account and use that for its end of MTLS. And so now you have MTLS end-to-end, you have encryption end-to-end, and if you need layer 7 authorization, that's when the waypoint proxy comes into the mix. If layer 7 is not needed, then the traffic just goes direct ztunnel to ztunnel. And then the CNI pod is then responsible for directing that traffic directly towards app-D unencrypted. So, if you look at the IPsec world for a second, the way we did this in IPsec is that, yes, your tunnel would form between the two proxies or two endpoints or two gateways, but then you also needed an access control list to basically decide if there's a traffic match destined towards this destination, well, then we'll encrypt you using that access control list and match. So that's the kind of high level of it. The other thing to consider too is this is just another visualization or visual representation of it. One thing to point out is that if you are trying to understand where the configuration comes from, Istiod still provides that configuration to the ztunnels, much like it provided configuration to the sidecar proxies. So you still get your encryption, but one thing to note is that this tunneling mechanism that is present between ztunnels and the waypoint proxy is offered up by Envoy's HTTP Connect upgrade. So Envoy recently had some features added to it to allow for this overlay construction to occur. Now, this overlay is actually a new feature, a new capability that was added into Istio, specifically for ambient mesh, and now as of 1.16 is also supported in the sidecar. This new tunneling mechanism called HBone, or the HTTP-based overlay network encapsulation, simply is a mechanism to carry HTTP inside of TCP. There's nothing special about it other than it's like another overlay network, similar to VXLAN or Geneve or even GRE for that matter. Except the other element is that it's carrying MTLS end-to-end. Now, interestingly enough, it's using port 15008 to be able to form the tunnel between, let's say, ztunnel on the client side over to the ztunnel on the destination resource. Now, there's not much more to this. If you actually want to dig into HBone functionality, there is a Go spec or a Go package where you can go read about the spec and better understand it. But if you actually look at the code under the hood, it is using VXLAN technology. All right. we're going to jump into the lab, but before I do, right, if you head over to the academy.solo.io, and if you actually did this self-paced version of the Ambient Mesh workshop, you will get access to the badge, assuming that you go through the workshop and you pass the quiz. The quiz just requires you to get 80%, and then you'll get one of these badges. Where's the Ambient Mesh one? Here we go. It's right in the center. So the Ambient Mesh one is a badge that will be presented to you, but you'll also notice that there are other workshops that you can take for other badges to add to your portfolio. And then lastly, one thing I'll say is if you want to, extend that conversation, join us on Slack. We'll definitely dig into some more details, but this is not the end of the presentation. We're going to get into the lab side of things now. Just, make note of this one Slack here, slack.solo.io, and then you can continue the conversation there. All right. So we're going to head over to yeah, go ahead.
Yes, Mourinho, a small question. I think there's one section called the waypoint, and waypoint is also a HashiCorp project as well. So people might confuse with those two terminologies. So can you let people know the waypoint from the HashiCorp and the waypoint in the Ambient Mesh, how those two are different?
Yeah, so the waypoint for HashiCorp is interesting because it's allowing developers to deploy and manage and observe their applications through a consistent abstraction of the underlying infrastructure. So it's more of a platform for developers to engage with the underlying tooling that supports their applications. It's actually has no relation to the waypoint proxy that exists in Ambient Mesh. So the waypoint proxy is actually different in that it's actually a resource inside of Istio, inside of Kubernetes, that is just looking for traffic. It's policing traffic. It's allowing or disallowing authorization from going on. But the two are very different pieces of projects and works, have nothing to do with each other. One is more catered towards developers, and that's offered up by HashiCorp, and that's actually a platform. It's more of a platform abstraction. The waypoint proxy is very much like the Istio ingress gateway capability. So I hope that clears that up. The two are very different and have no direct relationship to each other. So
yes, absolutely. And just a small comments. So TJ Singh Raina is saying the great start to the Ambient Mesh. Ahmed Chaudhary is saying player to have you back. So great,
awesome.
Some good appreciation. So now, Mourinho, you can start.
Awesome, great. So everyone should be at this point where they should be able to access this. If not, let me. I think I can drop it. I don't know how I can drop it off in the chat, but you should have access in the YouTube channel. There you go. Thank you so much, Simon, for doing that. So if you go to this playground here that Simon is sharing, you should be able to access something very similar. I'll be a little bit further ahead of you. Ooh, the sandbox expired. That's interesting. I'll start the track again. Maybe I must have done something. All right, I'm in. So you should see an instruction pane along the side here. Feel free to follow along in this pane as well. But if you have trouble reading it, or if it's not, I'll maximize this a little bit for everyone to be able to see. Make the screen a little bit more legible here. So what we're actually going to do in the very, very first step is we have to deploy a client cluster here. And the reason we need this is because we need a place to deploy our applications. We need a place to deploy Istio, specifically Istio Ambient Mesh. So the first thing I would say is copy these commands and paste them right into your terminal. And what's going to happen is it's actually going to quickly download kind and set it up, make it ready for our Istio deployment. And then we'll go ahead and check some things as well, just to make sure that it's up and operational. One thing I'll do is I'll duplicate this so that I can have this off to the side. And then I can just minimize this so we have a full screen for everyone here, because I want everyone to be able to see what's going on. Now you can have the instruction pane on your side as well, just so that it makes it easier for you to follow along. But I just want everyone to be able to see the entire console here. Now it's on its way to getting up the control plane node. I know it's using version 1.24, 1.26 is out and available. So you can actually jump into it and start using it. There shouldn't be any issues running Istio 1.16 either, even with its experimental branch for ambient mesh. But I highly recommend you use this playground because everything is set up for you. And I want you all to focus more on using Istio Ambient Mesh than actually having to build an environment to support it. So that being said, it's online now. So if I did a, oops, I have I have a big, I have all caps there, kubectl get nodes. We can verify that our nodes are on its way to getting ready. Ooh, why are they not ready yet? So we can go ahead and run this just to run the ready script to see what's going on. It's just getting some additional stuff. Okay, so it looks like it's ready to go. So with it being ready to go, now we can go ahead and download Istio. So there should be a wget command in the next little window there that you can copy over. And that wget command simply just downloads Istio CTL. And it's actually a special build of Istio CTL. This is what has ambient mesh. So this is why I say you actually need to go to the experimental branch to be able to make this work. Now, following along here, if you've downloaded the file and if you actually run the tar command there, it'll unzip Istio-ctl, it'll make it available. Now, if I do Istio-ctl, I think the command is profile list. Actually, Istio-ctl. Ooh, I must have done something, or I must have forgotten to do something here. /Istio-ctl. There we go. That's just because I didn't set up my environment variable to make it runnable from every location, but that's okay. We're just running it here locally. But if I do the /istio, and then I type in profile, and then I type in list, previously you would only see these, but you also now see the ambient profile here. The ambient profile is what enables ambient mesh. So there's a command there now that you can run to actually install Istio with the ambient mesh profile. So if I go istio-ctl install -y -set space profile equals ambient, this goes ahead to deploy ambient mesh inside of the existing cluster that I have. Now, once this is done, we're actually going to take a look and see the components running inside of our cluster. And then once that's done, we'll go proceed to deploy a service, and then we'll go on to do some very fancy ambient mesh things as well. I'm going to quickly check the chat here. Okay, so the link has been shared, so that's a good sign, which means we can continue. But if you notice here, right, look, waiting for daemon set istio-system ztunnel. Ztunnel is that proxy, the Istio CNI node, ingress gateway is deployed. So a lot of the same components are deployed, like Istiod and even the ingress gateway, but then the ztunnel as well as the CNI pod are installed as well. So if I did a kubectl get pods, or actually get all-n Istio system, you can run just the get pods just to verify. Let's start from the bottom, right? There's an HPA that handles the Istiod and ingress gateway in case they get overtaxed. There are deployments for this as well. And then there are services. There's actually a service IP, a load balancer service IP given to the ingress gateway. Now, notice here, there's also a daemon set, or two daemon set configurations, one for Istio CNI node and one for ztunnel. And actually, we can verify this in the pod deployment itself. If we look at the pods, I have 4 Istio CNI nodes, and I have 4 Istio CNI node pods, and 4 ztunnel pods. Now, interestingly enough, if I did a kubectl get pods -n Istio system -o wide, Notice that each one of these pods are deployed one per worker node in the cluster. This is because we're honoring the daemon set principle. For the daemon set principle, that means for every node that we have every node that we have running in our cluster, as long as it's not tainted in some way or labeled in some way to prevent a workload from running on it, we'll get a copy of this pod. Okay, so we know this is functioning as we expect it to. So Ambient Mesh is online, but it's not doing anything yet. So let's get it to do some things. But before we can, right, I think it's worthwhile also taking a look at the sample application that we have running. So let's minimize this, let's minimize that, and let's look at our fake service for 1 second here. So the fake service that we're going to deploy is actually going to be comprised of four different services. A client pod, or the sleep pod, that we're actually going to use to communicate with Web API. We're not going to directly, do things with Web API other than like execing into it and making curl calls. But Web API needs to go and talk to recommendation, and recommendation needs to talk to purchase history. Now, honestly, between these three, this is all plain text because I don't have sidecars going on here. But between client and Web API, I'll have a ztunnel going on here that prevents these three from communicating, or prevents this from just simply communicating in plain text. We can fix this because we're going to use MTLS as well. Now, let's go ahead and deploy the fake service. And you should see a command below to be able to deploy it. So if I go ahead and here click paste, the services have been created. And if I do a kubectl get pods, notice that all pods are now running, and that should be good to go. Now, if I do a simple exec command here, right, as you can see in the instruction pane, I'm actually execing into the sleep pod, and I'm making a curl towards the Web API. Do you think it'll be successful without looking at the instruction pane? It technically can, and it should, because I have nothing stopping it from communicating. So that looks like our web app's working. Now what we're going to do is we're actually going to expose that Web API service, right? And how we're going to go about doing so is we're actually going to use the Istio ingress gateway to do so. So in fact, if I go Control E, oh, actually I can't do that on this. So if I do home, because I'm using Windows, by the way, if you're all curious. And if I just remove all of this and type in cat, oops. Actually, let me do this and type in ls, because I think there are a bunch of files. Yes, there are two files here. There's a virtual service file and there's a gateway file. If I go back and type in web API -vs, this is the virtual service configuration. So if you missed last week or the last time we streamed, a virtual service is a definition on how we route to a particular service inside of a Kubernetes cluster based off of a host name derived from services. So this is like, okay, if I give you DNS, right, tell me how to get to the specific, backend. What this means is the Istio Ingress Gateway is listening in on this host, istioexplain.io, from this gateway. When I do receive requests coming inbound, I have a route to it to get to the Web API service. This is actually the fully qualified domain name if you didn't know that. And we're going to access this on this port number. Now, what I'll also do is show you the YAML for the gateway. This is the Istio Ingress Gateway, and we're writing a configuration for it. We're calling it the Web API Gateway. We're telling it, use the Istio Ingress Gateway to listen in on port 80 for this protocol for requests coming into this host. This is a host name, much like google.com, much like solo.io. And when I do receive requests on this host name, on this port, with this protocol, route it to Web API. Go to that service, the Web API service, and that pod is going to respond to that. Now, we need to go ahead and create this resource. So let's go ahead and remove that pound sign and apply these two services or two capabilities. And if we do a kubectl get vs, we see that the virtual service has been created, which means the gateway exists. And now if we go in to paste this export command, we're just assigning our gateway IP and the port number to it so that we can just simply call it on the curl command there. So now this root machine here, if I run a curl command against Istio explain.io using the gateway API variable or environment variable I just created, I should get a 200 success code. And I do, which means this works just fine. So that being said, we are done with module 1. We know that we have Istio Ambient Mesh online. We know we have an Istio ingress gateway that is allowing for us to make requests towards the web API service. And we're seeing a successful response because we've told the Istio ingress gateway to listen for these requests coming from our local host, which is my root virtual machine. So now let's move on to the second module, because all at this point we have done is just set up the control plane for Ambient Mesh and deployed our sample application and verify that it's working. Now we actually move on to the real stuff. We actually now move on to Ambient Mesh. So let me clear my screen. Let me just do something here. Okay, so I'm in the right module now. I just wanted to make sure that I wasn't jumping around too much. Okay, so what we need to do now is we actually now need to label our services. We actually need to label the namespace. So one of the things we do is if you actually look at this label here, let's label the default namespace with istio.io/data plane mode equals ambient. This is different than istio-injection equals enabled. This is saying let's turn on ambient mesh for this particular namespace. So the moment I do that, if we actually start running some logs, if we run the log command here, which if we do kubectl -n Istio system logs against any pod or resource that has the Istio CNI node label, well, here's what happens. What happens is we've actually now are looking for traffic for recommendation service, for the sleep service, for the web API service. We're basically now saying direct this traffic, if it's ambient mesh bound, towards ambient mesh enabled services as well. We're adding routes into the CNI node. This is effectively IP tables today, and this is a bunch of routing that happens at the CNI node. But this is very similar to how I just described how we do this with IPsec back in my old network engineering days. So nothing's really fundamentally changed here. We're just doing this with all the tools we have available to us. Now we can see that Ambient Mesh is now honoring directed traffic towards Ambient Mesh services. Now, what we're going to do is we're going to go ahead and generate some traffic, and we're going to go and see what goes on with that traffic. If I go ahead and run this exec command, which is I'm going to go target the sleep pod, and then from within the sleep pod, I'm going to run curl commands, 100 of them, towards the web API service. So the moment I do that, it's doing its thing. It's already made all of its requests. We're going to go check the ztunnel logs now. So the ztunnel logs are going to tell us a bunch of things. So we see we have an outbound tunnel right here. And it's saying to us, hey, we have to communicate with something, right? So if we look here, this outbound tunnel is targeting the sleep pod, saying, this is my outbound destination. This is the spiffy ID I want to associate with that outbound Z tunnel. And then if you see here, it's going to the web API service. So remember, this curl call that I made further up, which you can't see anymore, was directed from the sleep pod over to the web API pod. And we can actually see that in action because it's literally telling us, here's the spiffy ID for how these two communicate. Let's make sure that this traffic is encrypted. Now, one more thing I will point out is while this is talking about the traffic going between the two services through the Z tunnel, you see this capture outbound no waypoint proxy. I have this in place here because I don't have layer 7 authorization going on. I have no layer 7 policies going on right now. So I don't need a waypoint proxy. So let's go ahead and set up a layer 4 authorization policy, because what ends up happening is this won't get deployed, but we'll still see this in action, right? So there's a configuration here which allows us to deploy this authorization policy at layer 4. This is a default denial. So no one can talk to anyone until we start incrementally adding policies to allow people to talk to each other. So from my host, right, my little virtual machine over to Istio.io will not go through because I do not have a path to that actual service. Actually, I do have a path to it. I just have been blocked. I'm using a policy to block this transaction. So I can fix that. And the way I can fix that is applying a allowing policy. So there are a few policies I have to set up here, right? I have to set up an authorization policy to say, allow the web API to communicate with allow the sleep pod to communicate with the web API, allow web API to communicate with recommendation, and allow recommendation down here to communicate with the purchase history. Because in order for my host, my virtual machine here, to get a proper response to my request, web API needs to talk to recommendations. Recommendations needs to talk to purchase history. Once purchase history returns the values back to recommendations, which returns the value back to web API, I then get my response. But because I've created these policies now I should be able to flexibly communicate with my service from my local host. Now, if I try to deploy or use a service that's not in the mesh and that's not allowed, actually, this could be in the mesh, but with my layer 4 auth policy, it's not allowed because I haven't set up that policy. This request will fail, and it does. That's just a demonstration of layer 4 policies. In fact, all I'm really doing is honoring TCP ports and either disallowing the traffic if the traffic is not authorized, or allowing it if it is. This is different from layer 7 because now I can start implementing get operations, and we're going to explore that in the next module. So y'all should be caught up. Let me just swap into the next module here. And please don't do what I'm doing here. I'm just doing this so that you have full real estate to see my terminal here. So I'll start it on this side. I'll close off my window. Actually, let me just reopen it here because I want to point out something. In this particular module, what we're actually going to do is we're going to go from client sleep through the ztunnel. We're going to make a get request to the web API. This is a layer 7 get request. But because we have to go to the web API, and because this is layer 7, and because this is HTTP, the waypoint proxy comes into the mix here, and will honor those policies and either allow or disallow based off of what that policy says. So let's go ahead and get that configured. But one thing I will point out is the Kubernetes Gateway API is used today to deploy that waypoint proxy. Now, we're going to use the Gateway API spec to create this waypoint proxy. So take a look at this. So this is the Gateway API spec, right? Gateway.networking.k8s.io. We call it Web API. We've given it an annotation so that it knows to tie to the Web API service account that lives inside of the Istio mesh. And then we're giving it a gateway class of Istio mesh. So the moment we apply that, if I do a kubectl get gateway, there is my Web API gateway API. So now let's go ahead and just get the pods that demonstrate that it's a waypoint proxy. And in fact, if I do a kubectl get pods, you'll see that the Web API waypoint proxy is there inside of the same namespace because it's now doing policy work for this Web API service here. Now we're going to go ahead and create an authorization policy at layer 7, right? So let's go take a look at this. This layer 7 authorization policy is still targeted towards the Web API, but it's originating from the sleep pod. So meaning my sleep pod is going to make a request out to the Web API. And one of the things it's going to do is it's going to make a GET request. So it's only authorized to make a GET request. It's not authorized to make any other kinds of requests. So the moment I implement that, this tells me only Sleep can make an HTTP GET request. It cannot do anything else. Let's test that out. So if I run a quick HTTP GET command, right, this goes through just fine. And the reason why is because this is a simple curl command, and it defaults to using HTTP GET. But if I try to send a delete request, right, kubectl exec deploy sleep, I'm still using the same pod, and then I've passed in the x delete flag, access denied, access denied. This is a role-based access control. This is a layer 7 authorization. This is the waypoint proxy saying, no, you cannot delete anything inside of the web API service. So this is how layer 7 authorization works inside of Ambient Mesh. We actually use this waypoint proxy to enforce that. Now, we can also gain some observability as well and metrics from the waypoint proxy, because all it's really doing is it's just pointing out Prometheus stuff. This is all written in Prometheus format. And what that really means is it's telling us Prometheus style, which we can then derive and pass to any other observability system that we wanted to, the number of requests that went through and the number of requests that actually failed to go through as well. Now, there's a couple of other things here. We're going to do fault injection. Basically, what we're going to do is we're going to inject a very small delay, and we're going to see that the functionality still stays the same when it comes to Istio service mesh. So let me just quickly clear my screen so we have some.
I didn't get that. Could you try?
Sorry, Siri, I wasn't talking to you. I was talking to my audience. So let's go ahead and paste this virtual service configuration. I'll quickly walk you through it. So in this virtual service configuration, all I'm doing is I'm telling, anytime I am coming through this web API gateway, which is the ingress gateway that we specified earlier, inject a delay of 5 seconds, 100% of the time, anytime I'm using the header using Amy, and if I'm going to this destination. Otherwise, if I'm not using Amy as a header or a header flag or a header attribute, then just go directly to the service. So the moment I implement this, right, if I run a regular curl command, so this is with Amy right now, but if I actually remove this, actually, if I go home, do a pound, home, remove the pound, and then remove the user Amy. Oh, and remove the -h as well. We don't need the -h. You see how it successfully goes through just like that, like super quickly. But if I go back, right, and remove the pound sign and specify the header user Amy, 1, 2, 3, 4, 5-ish. Okay, 5 seconds-ish. Sorry, I was a little off there with my timing. But you see that it took about 5 seconds for us to get that response time. And that just means that I can still implement resiliency into my microservices. Okay, I will say we're almost done. We have one more section here and then one more module. That last module is really about how do we do both ambient mesh and regular Istio. But before anything, right, if we wanted to do a traffic shift service, let's go ahead and deploy a traffic shifting configuration here. So actually, we've deployed the traffic shifting here, but I want to also show you what this looks like before I even apply it. So I'm just going to remove this. I'm just going to do a quick cat. Now, this deployment simply has deployed version 2 and version 2 of the purchase history, which means we have 2 versions. So if I do a kubectl get pods, you see that I have version 1 and version 2. Okay. Now we're going to go ahead and create a brand new gateway or a gateway spec because we need to be able to do this traffic shifting at layer 7. Okay. So we've created our gateway. So if I do a kubectl get gateway, I have 2 now. I have a purchase history gateway, which is going to route between version 1 and version 2, and I have a web API gateway. Interestingly enough, right? Sidebar. I can do this with the gateway API spec as well, where I'm using canary releases, or I'm doing a dark launch of version 2, and then I have to route traffic to version 2. I can achieve this with just the gateway API spec, but this becomes challenging at scale. So this is why we do this with Istio. Now, we're going to deploy a virtual service with an associated destination rule. And in this virtual service, if you notice here, right, I have set a weight where 90% of my traffic will go to version 1 and 10% of my traffic will go to version 2. Okay. I also need to define a destination rule set here, which translates my version 1 and version 2 subsets to their respective ones inside of the cluster. Meaning, while this tells me how do I route to these and how do I distribute my traffic, this destination rule here is saying, here's the translation of the subset to the actual service itself. Meaning, this label will map to the purchase history service, and specifically version 1, while this one maps to version 2. So the destination rule has been created. The virtual service has also been created. Now, if I run this curl command here, right underneath that configuration, I want you to pay attention to something here. This virtual command actually has the -c flag, which only will tell me how many instances went to version 2. Now, if we run this command, I know 10 instances will go to version 2, or approximately 10 instances. But if I do this, here's what you'll get, right? You'll get 8. 8 out of the 100 requests went to version 2. This is an approximation. So the load sharing here is an approximation. It's never going to be a guaranteed 10%, right? It'll be approximately 10%. Let's adjust this quickly, right? Let's remove the purchase history V, and let's, the 2, and let's just remove the -c. And now you see that some requests went to V2, while some requests went to V, or the majority of requests went to V1. You could sit here and count them, and you'll probably get approximately anywhere from 8 to like 11, 12 that went to V2, while the rest all went to V1. But now we know that traffic shifting works. Now we know that fault tolerance and injection works. What about when I have services going from ambient mesh-based services to non-ambient mesh or regular Istio? Let's go explore that right now. Oop, something is wrong. Something went wrong. Interesting. Okay. I'm not sure why it's taking or going through this. I might have missed a step, but this is interesting. Okay. I hope y'all are not getting this too, because that would be very uncool, and I didn't expect this to occur. But here's what I recommend, right? I'm actually going to go back. I'm going to exit. And what I'm going to do is I'm actually going to stop the challenge. And what I'll do is I'll skip to that last challenge there. Hopefully it's not the same for you. If it is, I'm very sorry. But what I recommend you do is jump right to that bonus track. That bonus track is Istio Ambient Mesh with regular Istio workloads. We'll quickly go through that. And in the meantime, let me just go and scan the questions section. Okay, if it works for you, great. Keep going. And just wait for me to get my environment up and running. But let me come in here and answer some questions. How flexible is the policy? Can you set up a policy where pods from outside the mesh have access, but not certain pods within the mesh that are not authorized? Yes, you actually can. It actually will come down to how you label certain resources, because you can use labels and you can manipulate labels to basically leverage policy as well. So then you could use a label to basically say, any workload with this label can talk to workloads with that label. So you basically can go ahead and leverage that for non-meshed workloads. Awesome, Ahmad. Thanks for completing the challenge. I'm just waiting for mine to load up.
Yes. So, Mourinho, one quick question. When this is a while being loading, so let me know. Let people know about what is the difference between the policies that we are talking about, and what are the policies that the network policy CNI gave us, because that's question always jump into the people's mind, like how the network policies are different for those policies that we are addressing currently.
Yes, so there is some overlap actually with layer 4 policies and the Kubernetes network policy resource. What's interesting is that how that policy takes effect. So when you think of layer 4 policies from the lens of a CNI or the network policy resource, what you're effectively doing is you're using Kubernetes to make that decision. You're actually forcing the kernel to make that decision around which traffic is allowed versus which traffic isn't allowed, which is fine. It's effectively IP tables, and it's effectively the node proxy that is doing this, or more specifically, the kube proxy that it's doing this. Now, that being said, right, the layer 4 authorization policy within Istio or Istio Ambient Mesh is different in that it's actually using the ambient mesh ztunnel to enforce this policy. So what ends up happening is, as traffic is about to reach that ztunnel, the ztunnel has to make a determination on whether or not this traffic is allowed to be authorized to communicate. If it's not, the traffic request is dropped, meaning it won't go through. So this is different. This is actually fundamentally different. This is a mechanism to basically return a value saying you are not allowed, which is different than actually dropping the packet at a layer 3 and below level. So, or filtering that packet. So we're actually talking about filtering packets versus filtering requests. If I filter a request, that request actually on the back end may still go through, but we are actually returning a message to that client saying your request is not authorized, and therefore you won't get a response. Whereas with the network policy resource, normally a message isn't responded or replied to. It just says that the destination resource is unreachable or is not allowed to be reached. And this is like a firewall saying, I'm going to block your packets. So that's a fundamental distinction, as well as who processes this request. So if it's a layer 3 packet request, Kubernetes will process it. Actually, the node processes this. If this is a layer 4 Istio authorization request, Istio's control plane enforces this request using the ztunnel. All right, we have a few minutes left here, so let us get going with this. All right, now with the overlap with CNI network policies, is it possible to shift to a completely Istio-driven policy, or does kube proxy still have a role? Kube proxy still does have a role because not everything in your cluster is going to be using Istio for networking. Remember, there's a control plane that exists that relies on the Kubernetes control plane to push around traffic as well. It seems a bit counterintuitive to leverage Istio to protect itself, or even provide networking for itself, because that would actually cause confusions from a networking stack point of view. So this is where the control plane relies on the extended control plane of Kubernetes to be able to process its own requests. Okay, so we're going to create another namespace here, right? And this namespace is going to be called HTTP bin. So I'm not going to close this off, but I want you to follow along. And we're going to label this namespace for Istio injection. Okay, so if I do a kubectl get ns -- show labels, you notice the default namespace has an istio.io / data plane mode equals ambient, whereas the regular Istio version has an istio - injection equals enabled label. Now, we have no services in the HTTP bin namespace yet, so we're going to deploy a service account, a service, a deployment, and we're going to have something that is going to start making a request. So if I do a kubectl get all -n HTTP bin, you will see that I have a pod that it's up and on its way, but oh, notice 2 out of 2. If I do a kubectl get pods, hold on, let me just do a get pods, it's 2 out of 2. But if I do it on the default namespace, it's 1 out of 1. So this default namespace is ambient mesh enabled. This HTTP bin namespace is Istio service mesh enabled with the sidecar, and that's the sidecar running. So we've got this up and online. What do you think should happen? So if I make this request right now, right? If I go from my if I go from my sleep pod from within the mesh, ambient mesh, by the way, over to this HTTP bin service that is located in another namespace that is sidecar enabled. So sleep pod, no sidecar, but in ambient mesh going through the ztunnel towards a sidecar resource in regular Istio mesh, because they're both in the mesh and because I haven't set any policy to disallow them, this request goes through just fine. The reason why is because Istiod treats all of these resources as trusted resources anyways, until we start putting in policies in place for layer 7 or layer 4 authorization. Once we put those policies into effect, then technically speaking, this sleep pod shouldn't be able to communicate with this HTTP bin service, vice versa. But in our case, we're talking from an ambient mesh enabled non-sidecar resource to a non-ambient mesh sidecar resource. So I have regular Istio alongside ambient mesh Istio, and workloads can talk to each other. And that brings us to a wrap in this workshop. So that being said, we covered a number of things here in this workshop. I'll actually use this as a backdrop quickly, right? And what we've effectively demonstrated is that we have 2 nodes or multiple nodes in a cluster. We have multiple services running inside of our cluster. And we're using the ztunnel functionality to tunnel traffic from client here over to one of these services over here. One of the interesting things is that identity is derived from the service account of this one service, and the ztunnel on this end will assume the identity using SPIFFE format, and this ztunnel over here will do the exact same thing. And this forms the basis for our encryption for MTLS. The additional thing to consider here is the waypoint proxy. When I need layer 4, then the waypoint proxy does not exist, and I just do straight ztunnel to ztunnel, and the ztunnel enforces my layer 4 authorization. When I need layer 7, my waypoint proxy gets deployed using the gateway API spec. And with that gateway API spec, I'm able to define a natural Kubernetes native resource, but I'm able to write my Istio abstractions on top of it and say, look, I have a layer 7 policy I need you to honor. If there is a layer 7 GET request, allow it through from app A to app D. But if there is a layer 7 delete request from app A to app D, disallow it. And that's effectively how ambient mesh functions. We also did see that ambient mesh can function alongside the regular Istio mesh under the same control plane. That being said, I am done sharing. One thing I will point out, any more questions, hit us up on Slack. Come to slack.solo.io, and you're more than welcome to engage with us and ask us any questions about ambient mesh. If you're on Twitter, feel free to reach out to me. I'm happy to answer questions there as well. Simon, back to you, buddy.
Thank you very much, Mourinho. It's been another great session with you. So spent 2.5 hours with you, and I think learned a lot of good stuff around Istio. And I think these technologies is not so simple. It's very complex because service mesh required to have a knowledge of Kubernetes and some other very, very gateway APIs. But when you listen to Mourinho, the concept look very simple and easy to grasp. So power of his explanation, I think he will keep up his teaching skills, keep up and running next year as well. So it's been a great session for me. So before I let you go, but first share some plan, because Ambient, I look at it, I think there is the traffic mesh. I think I pronounced his name correctly. Traffic mesh. They come up with this notion of removing the sidecar because it's at some limitation, the CPU, the resource utilization. There is not everybody need a sidecar. They think about it. So they coin this thing. Let's remove the sidecar and use the daemon set and do the same thing. But how this approach is different from the eBPF service mesh approach, because that's another topic, another community is driven to. So how these two approaches are different, and what's your point on these two different approaches?
Yeah, so eBPF itself doesn't implement a service mesh. It's more in-kernel functionality to be able to create sandboxed applications. I know what you're referring to. You're actually referring to the Cilium service mesh itself. In fact, what goes on is The Cilium service mesh leverages eBPF to direct traffic towards a very similar tunneling mechanism. But the other thing to consider, though, is that with the eBPF, Cilium-based service mesh, it also deploys a node-based Envoy proxy. That Cilium service mesh it's in its infancy, so I wouldn't even call it production ready at this point. But it's something interesting to explore, because if you're starting from the path of a CNI, you may be able to, consider using a mesh at that point, but it's not going to be a complete solution for you, because when you think about what goes on at layer 7 and the richness of attributes and data and even decisions that we can make at layer 7, the Envoy proxy, even the proxy that's being developed in Rust, makes for a very hybrid and highly capable multi-architecture style of environment. What that means is I may have several different workload environments, one requiring the full functionality of Istio, while another one might be requiring ambient mesh functionality because I don't want to deploy sidecars. Think of the edge, for example. Think of edge computing. Edge computing has a lot to take advantage of when it comes to sidecarless approach and ambient mesh, because we're all about reducing how much resources we consume at the edge so that we can maximize on the application stack that we can deploy there, especially since we have a very limited footprint. If you look back here, you see those NUCs down there, they're edge devices, right? And I'm actually experimenting right now with them to be able to run ambient mesh at the edge. So I'll deploy a node here. I'll take a node over to my father-in-law's place, drop it there, see how applications run. And I plan on using Civo Cloud as my main hub kind of setup. But why I bring this up is because using a CNI, right? And let's talk about networking for a second. A CNI to me is actually a networking switch. If you're going to have it depend, or if you're going to depend on it to move traffic very, very quickly, that means that it's not going to have all the power to do things at layer 7, right? When you already have systems that are built for layer 7, like the Istio service mesh, it almost feels like you should be using both versus one or the other, right? So you actually need to think of the full network stack, one that actually moves your packets very quickly, but another system that actually looks at the richness of the data and allows you to make decisions based off of that richness and telemetry and even attributes of those various requests going on. But here's the thing too, how do you manage these two? How do you separate, you have this one tool here, this other tool here, how do you bring them together? Well, there are ways you could do this yourself, or you could come to us. Solo offers the Glue platform, where it offers up Glue networking with Cilium and the Glue mesh capabilities with Istio. And it joins those two forces together to give you a very solid platform for a solid application and API networking experience. So go check it out. Come ask us, come talk to us. We'll tell you more.
Yes, and one final question, you mentioned, is not being merged the ambient mesh into the main repository. So the ambient mesh is also, it's going to be going into the same repository, the main Istio repository, and it's a part of it. And people can make forks on anything, added new functionality, raise and PR, submit an issues on that. So on top of that question, another one. So there is, I think, not a Rust-based things in Istio before that. There's an Envoy proxy. So now the main repository is also adding code for the Rust in itself, this main repository. So how do things work on the side of coding and maintenance for the open source project?
So interestingly enough, the Rust implementation is also a separate branch. If you actually go into the istio.io repo, you'll see that there's a fork specifically, there's a branch specifically for ambient mesh and another branch specifically for the Rust implementation of the sidecar proxy. So everyone can even go in there, test this out, file an issue, provide their feedback, because here's the thing, it's an open community. But the one thing to consider is if you want to contribute to any of these two projects, right, the Rust or even ambient mesh, there is a contributing guideline that I highly recommend you take a look at. It'll give you a sense of what you need to do to be able to file a PR or create an issue against any one of these branches and provide your feedback. And the reason I bring this up is because I also encourage y'all to go into those repos and test this stuff out. Make your observations, make notes, and then come back and add this stuff so that we can go in and make it better, right? Our director of open source, Lynn Sun, she drives a lot of the activities, especially for both Ambient Mesh and Rust inside of the Istio community. So she would welcome any kind of feedback that comes our way. If you also want to, contribute, you're more than welcome to. There's no gatekeeping here. We want everyone to participate.
Yes, and final question. Istio gone. Is it coming up later next year? Or do you have plans to go there on talks?
Yeah, so IstioCon, I think there's going to be a shift in when that occurs, and I think what they're trying to do is align this to the CNCF stuff. So if you're having a KubeCon, then chances are IstioCon might be there. And the reason for this move is because of what went on with Istio moving into the CNCF as an incubating project. Because it's in that state right now and it's on its way to graduation, what that implies is that now we can really have sessions both at KubeCon and even at the CNCF side conferences as well. So I expect IstioCon to show up in KubeCon EU, or the event that's happening in Amsterdam mid-April, but I'm not 100% certain for that because they're still working through a lot of different logistical stuff at the moment, especially since what the CNCF has done is they've actually narrowed down the number of days and whatnot, obviously to allow people to rest and travel in a suitable amount of time. But that being said, right, stay tuned.
Yes, absolutely, absolutely. I think this. So I think CNCF take a moves from 5 days to 4 days because traveling is a lot of mess. Previously, you have to travel on Saturday and Sunday to book your flight, and then go on the Monday, and then the 5 full days, and you will experience the jet lag and so many other things during those flying. So I think they take a good move of making a 1 day, I think, co-located events and the 4 days of the full KubeCon. So I think it's all about the community feedback that they receive from the community. And Mourinho, I think you will. What is your vacations plan? Because you definitely need a break.
Oh yeah.
Amount of.
So it's funny. I actually have one more workshop I have to deliver on Wednesday. It's actually an ambient mesh workshop, so very similar to this. After that, I am offline until I think January 3rd, because like to your point, Simon, I've been traveling all over. I've been doing so much. I haven't really given myself like time to just sit there. I want to like game. I want to spend time with my son. I want to go out and do things with my family. Plus, it's like the holiday time, so I really want to just catch up on like a lot of the shows I want to binge on, and that's how I relax, right? But at the same time, like it also opens me up to being able to have coffee chats with people, and even you, Simon. So everyone's welcome to reach out if you want to, have a brief chat over the holidays or something like that. That's what that time's for.
Yes, absolutely. I think I able to find a wonderful guest for the next year as well. So I really like your teaching style. So I would definitely encourage you to continue this journey on, because it's helped a lot of the people, because service mesh is always been challenging to learn some of the concepts, toughest concept to learn about it. So it's been I think you will continue your teaching style in the next moving year as well. So keep an eye out. And this has been I think, like as you mentioned, it's too much time inside of the camera and the live stream. This is actually my 13th workshop of 2022. So it's been a lot. I don't even imagine how much time I spend with a lot of the community. We started off with the V cluster with the Ingen theory. And in February, and when in the March, I've done a podcast with Michael Cade on Cubester. In I think May time frame, I did a podcast with the KDA team on Kubernetes event-driven auto-scaling. Then I have done a workshop with KubeCost, the Podman, Victor Farsik on Crossplane. I did a workshop on Docker 101 with Michael Irwin, DevOps Roadmap with Michael Cade, Linux and Container Fundamental with Ivan, and how to enable building control plane with Crossplane with Daniel Magnum, and 3 workshop on Istio, 2 of you and 1 from Rohit Gumare. So it's in 13th workshop. So I will try to definitely do more in the next year. But it's been incredible. I think you come up with a wonderful strategy of how you organize it. Like we have a playground, people can watch it, do all these kind of activities, because previously we don't have those kind of activities and people get boring. But this seems to be a very good experience. To I will continue to do those kind of workshop in the near future as well. And also tons of appreciation for the solo team of pulling this up, because it's not been a 1 day effort. I think this is a 4 month of effort. It's been a lot of journey and making sure those the content is always stays aligned with the CNCF, the open source project, and so I think a ton of appreciation to all the solo team. So go check that out. There, people are doing hard work on making people life at Service Mesh. So go check that out. And thank you very much for tuning into the last podcast, last workshop of 2022. And we will try to will get back on 2023. But meanwhile, enjoy your vacation, spend time with your family and holiday families, because we all need rest and we all need to take a refresher to continue your 2023 journey. Thanks, everyone. Stay safe, stay healthy. Have a wonderful 2023, everyone.
Take care, everyone. Thank you so much, Sam. Cheers.